During this session, we'll give you a brief introduction to lingwomatics and why we're qualified to speak on this subject. We'll explain how text mining works even if you're very new to the area. We'll help you understand the difference between text mining and keyword search, which is the approach that most commonly used search engines take. And at the end, we'll provide you with some options to find out more information.
So text mining is simply the process of distilling actionable insights from text. It is simply too much information to help you navigate around town. This is like a bunch of text that you couldn't possibly read and organize quickly, like a million tweets or the entire works of Shakespeare. You need to reduce the information in the map. Text mining works in the same way. You can text mine a bunch of tweets or all of Shakespeare to reduce the information just like this map. Reducing the information helps you navigate and draw out the important features. This is a text mining workflow. After defining your problem statement, you transition from an unorganized state to an organized state, finally reaching an insight. The text mining workflow can be broken into 6 distinct components. Each step is important and helps to ensure you have a smooth transition from the unorganized state to an organized state. This helps you stay organized and increases your chances of a meaningful output. The first step involves problem definition. This lays the foundation for your text mining project. Next is defining the text you will use as your data. As with any analytical project, it is important to understand the medium and data integrity because these can affect outcomes. Next, you organize the text, maybe by author or chronologically. Step 4 is feature extraction. This can be calculating sentiment, or in our case, extracting word tokens into various matrices. Step 5 is to perform some analysis. This course will show you some basic analytical methods that can be applied to text. Lastly, step 6 is the one in which you hopefully answer your problem questions, reach an insight or conclusion, or in the case of predictive modeling, produce an output.
First, let's start with something that most of us use every day, keyword search. Most search engines take this approach, and it's important to understand what is going on when you use them. Typically, you type in one or more keywords, in this case, breast cancer, and the search engine then finds all the documents that have those keywords in them. The important thing to understand is that the search engine brings back links to the documents. It tells you that this list of documents here all contain the words breast and cancer. Then it's up to you to read through each document and decide whether they are of relevance. Keyword search is useful and most people use it every day. It's generally good enough for when you're speculatively browsing around for information. For example, I may want to look for places to go on holiday or find a specific website such as the website for Microsoft. It has significant limitations when the set of results from your search are very large. Most people don't have time to go through hundreds or thousands of results. Each result corresponds to a document, and it becomes completely impractical to go through every single document. So what is text mining? To explain it in simple terms, it's the ability to process unstructured text, typically in a very large set of documents such as thousands or even millions, interpret the meaning and automatically identify and extract out concepts, as well as the relationships between those concepts to directly answer questions of interest. By applying the technique just described, text mining systems like I2E can automatically identify and extract concepts, the relationships between them, or the actions performed on them, and then present them as facts or assertions. So the user is presented with a set of facts or relationships to analyze instead of a set of documents. If we take this example, which is the question, what genes affect breast cancer, running over many different document sources. The keyword-based approach finds all the documents that match one or more words depending on what has been typed in. These are presented as a list of hits, but to analyze them you have to read through each document to determine the relevance. In the text mining approach, the question can be expressed in an open way. I2E uses built-in vocabularies to expand out all the different ways genes and diseases can be expressed in the literature. It automatically extracts out the concepts, in this case genes and breast cancer, and finds the relationship between them using its natural language processing engine. The results are presented as a set of facts, relationships and assertions with links to the original document for when additional context is required. This approach makes it much faster and much more efficient to analyze the results and get to the right answers.